Dear students, welcome to today's class. Today I am going to explain a very important topic, that is differentiability of a function. What is the differentiability of a function? What is the need of learning differentiability of a function? Okay, so without wasting our valuable time, so let us start our class. So in mathematics, we are very interested about tangents of a curve. Let us see here x-axis and y-axis. There is a curve y is equal to f of x. There are so many curves are there in mathematics. There are so many curves. On the curve, there are infinite number of points will be there. Let us take one of the point is px1 comma y1. One of the point is x1 comma y1 on that curve y is equal to f of x. This may be sine curve, maybe tan curve, or e power x curve, a power x curve, signum curve, modulus of a function curve, whatever may be that curve. Let us take one point on that curve. We know the definition of tangent of a curve. What is the definition of tangent of a curve? It is a line which touches the curve at only one point. It is called tangent of the curve. We know that it is tangent of the curve. At the point P is called point of contact. This P is called point of contact. Understand this? Now I am very interested to find the equation of the tangent. I want to find out the equation of the tangent. To find the equation of the tangent, we should know at least a point on the tangent and very important slope of the tangent. Slope of the tangent value. So there the great mathematician worked heavily on this line, that is tangent, how to find out slope of the tangent given a curve and a point on the curve. So to find the equation of this tangent, we required a point, already given point. We have to find out the slope of this curve. Then how to find out the slope of the curve? That is the main research area that trigger the whole world. Okay, now, right. This is the first one. The second concept is this differentiability will give the smoothness of the curve. The smoothness of the curve. The smoothness of the curve. For example, how far it is smooth. So if you see here, the curve is smooth at this situation. Here it is smooth. Here it is also very smooth. How far smooth is there? But it is not here, it is not smooth. Smooth means what? Curve nature. If it is a curve nature is there, smoothness is there, then only we can able to draw the tangent at that point, at that smoothness. So these are the major 2 points, major 2 topics that we are more concentrated in the differentiability of a function. So our aim is to find the slope of a tangent, slope of a tangent for a given curve at a specific given point. Understand? So that is our main aim of this today's class. Then how to find out the slope of the tangent? So I will going to explain very detailed explanation I am going to give. Okay, now? So let us start our class. Now I am going to find out, I am going to explain how to find out slope of a curve. Okay, now slope of a tangent, sorry. So for this, let us take a 2-dimensional system, that is x-axis and y-axis, it is origin. Okay, now let us take a curve. Let us take a curve. This is y is equal to f of x curve. Okay. Now I am going to check. Let us take a point A whose coordinates are x is equal to a. Therefore, at A, its coordinate is a and y coordinate is f of a. At x is equal to a coordinates are a comma f of a. Y coordinate is f of a. Right. Let us take another point B. So, where we have to take the B, that means x is equal to a plus h. A plus h means what is your h? H is a very, very minute quantity. H is a very, very minute quantity. For your understanding, so I am not explaining about this neighborhood, related neighborhood, all those things. I am not going to touch that. Just I am taking here x is equal to a, here x is equal to a plus h. A plus h means just it is besides of a only. For your understanding purpose, I am drawing somewhat little bit distance. Now, what are the coordinates of B? So, the x coordinate is obviously a plus h comma. What are your y coordinates? F of a plus h. Very nice. F of a plus h. So, on the curve, I have taken 2 points. One is A and another one is B. The coordinates of A are a comma f of a. The coordinates of B are a plus h comma f of a plus h, where h is a very, 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 very small quantity. So, we call it as a infinitesimals. That means, this a plus h value is just beside a. Just beside a. That means, if x is equal to 2, then your x plus h is 2.000001. Just it is beside. For your understanding purpose, I am drawing a little bit distance. Now, let us draw a line which passes through this point. This is tangent. So, here what we call it as AB is secant of the curve y is equal to f of x. Secant of the curve y is equal to f of x. Already we know the definition of secant. A line which intersects the curve at the distinct points is called a secant of the curve. Now, let us see that what is the slope of the secant. We know the slope of the secant. Why? This secant passes through the point a comma f of a and b a plus h comma f of a plus h. We know the slope of the secant. Secant line AB is equal to m is equal to, you know the formula, difference of y coordinates upon difference of x coordinates. That is, if it is x1 y1, this is x2 y2. y2 minus y1, that is f of a plus h minus f of a by. So, this you call it as x1 y1, this is x2 y2, y2 minus y1 upon x2 minus x1, that is a plus h minus a. This is equal to f of a plus h minus f of a by h. Remember that here h is not equal to 0. Remember that h is not equal to 0. Why? Because x plus a and x is equal to a, x is equal to a and x plus a, h are both are distinct points. Both are distinct points. That means h is a very, 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 very a minute value. It tends to 0. It never equal to 0. That's why here no nothing wrong in it by dividing h. Okay, now let us observe the process. Let us observe the process. As h value tends to 0, as h value approaches to 0, as h value nearer to 0, close to 0, what happens? Let us see that. That means as h value nearer to 0, this point moves towards x is equal to a. Understand this? That means you will get the curve, the secant the secant will get like this. A will be fixed, this point B will be no. So, here you will get B. Next you will get here B. Next you will get here B. Next you will get here B. Next you will get, next here you will get A, B, both will coincide, not coincide at a situation. That means as H value tends to 0, B approaches to A. B, that means here A plus H approaches to A. H value tends to 0. If you goes on increasing 0, this B value is also approaches to A. That means at the situation, at some situation, then the secant will approaches to tangent. The secant will become a tangent. It cannot be a secant, cannot be a tangent, but as H value approaches to 0, your secant will become acts as a tangent. That means what? As limit value H tends to 0, that is f of H minus f of A upon H. That means as H value tends to 0, in this as H value tends to 0, this will become the slope of the tangent. Slope of the tangent at A. Understand this? Slope of the tangent at A. This is called derivative of this function. Derivative, we call it as the derivative of the function. Okay, now, right. That means this is called, here we approached the x, that means here from which side? Right hand side. From where we are approached? We approached from right hand side. That's why this is called right hand side derivative. Right hand. So this is denoted as f dash of A plus, this is equal to limit H tends to 0, f of A plus H minus f of A upon H. So this is your right hand side derivative. So you are approaching. So this whatever the value, this limit value, it should exist finitely. It should exist finitely. That means you should get a finite value. If you get finite value, if you get a finite value means you should get a real number. You should not get any 0 by 0 or infinity by infinity, infinity minus infinity, such type of values you should not get. If this limit exists finitely, that limit value is called the derivative of the function y is equal to f of x at the point A. That value, whatever may be, this value will give slope of the tangent. Okay. This is called right hand side derivative. Now there is a naturally one more question arises. Sir, you are approaching x is equal to A from the right hand side, right hand direction. If you approach the same x is equal to A from left hand side, let what happens. So let us see that situation also. Now welcome to this class. Now let us see what happens in this situation, that is x axis and it is y axis and it is origin. Okay, now let us take a curve like this, y is equal to f of x. Okay, now there is a curve y is equal to f of x, and more precisely I will draw like this. So let us take the curve like this. Okay, if it is very easy, y is equal to f of x. Okay, now let us take a point A on the curve y is equal to f of x. Let us see the coordinates of this curve. X is equal to A. What are the coordinates of A? So the coordinates of A are x coordinate is A, y coordinate is f of A. Let us take another value which is left side of A. That means generally on the number line, the number which lies left side means A minus H, where H is a very minute quantity. So previously we have taken from right side A plus H. Now we are taking A minus H to the left side of A. So let us take this point as so what are the coordinates? This is a B point. What are the coordinates of B? The x coordinate is A minus H. What are the y coordinates? If x is equal to A minus H, what are the y coordinate? F of A minus H. So I have selected 2 points on the curve y is equal to f of x. where a is equal to a comma f of a and b is a minus h comma f of a minus h. Dear students, once again I am telling, this point is just in the neighborhood of a. Neighborhood means just beside, just left of a. That means here only it will exist, here only it will be this, where just the left side of a. As h tends to 0, h value approaches to 0, this total b value approaches to a. Okay, now let us draw the, so this is a, what you call that, secant AB. So AB is the secant of the curve y is equal to f of x. Now first I will find out the slope of the secant. Slope of the secant AB is equal to m is equal to formula y2 minus y1 upon x2 minus x1. Okay, you take it as a x1 y1 and this is x2 y2. x2 y2. Now what is this y2? F of a minus h minus f of a by x2 means how much? A minus h minus a. A minus h minus a, right. So this is equal to plus a, minus a will get cancelled. So this is equal to f of a minus h minus f of a whole divided by minus h. Okay, that is the slope of the secant AB. Yes, as usual, if as h value approaches to 0, what happens? Your h value approaches to 0, the b value also, here b will be there, so there will be a secant. Here b will be there as your secant. As h value still approaches to 0, as h value approaches to 0, b approaches to a and the secant is also approaches to tangent at a. Tangent at a. That means what? As limit h tends to 0, f of a minus h minus f of a upon minus h. So this is the slope of the secant. Slope of the secant. As h value approaches to 0, the secant will become tangent. The secant will become tangent. Therefore, whatever may be the value it comes out, output, it should exist finitely. It should exist finitely. Finitely means you finite value, some finite value you have to get root 2, root 3, minus 1 by 2, minus not 0 by 0, infinity, such a type of, if exist finitely, whatever may be the value you got, this value is the slope of the tangent at a. The slope of the tangent at a. This is called left hand side derivative. The left hand side derivative at the point x is equal to a. This is denoted as f dash of a minus. A minus means what? The minus sign indicates that you are approaching x is equal to a from left side. You are approaching a from left side. Okay, now right. So this is the formula for left hand side derivative. What is the left hand side derivative formula? F is equal to a minus is equal to limit h tends to 0, f of a minus h minus f of a by minus h. So remember this minus h minus h. For right hand side plus h, like that you remember. A minus h, here minus h will come. Here f of a, of course there also f of a. Here if a plus h for right hand side. For left hand side f of a minus h denominator. Understand this? So this is a left hand side limit and previously it is a right hand side limit. So now observe the situation here. To exist a tangent at a, both left hand side and right hand side, these two tangents, both sides it approaches to a. Then only there exists a tangent at a. That means if you want to find out the derivative or slope of a tangent at a point x is equal to a, both its left hand side derivative and right hand side derivative should exist separately they should exist, and whatever may be the output value will come, that should be equal. That means left hand side derivative and the right hand side derivative should exist. If both are separately they should exist and those should be equal. Whatever may be the value that will come out, that gives the slope of the tangent at A. Understand here? Okay. So this formula, this is a length formula. For this formula, there is a short formula is also there. Now I am going to explain that short formula. Given a point x is equal to A, for a curve y is equal to x, we know this left hand side derivative and right hand side derivative formulae, or just now we derived. Those two formulas also, those two values exist, these two limits should exist first of all separately, and those two values should be equal. That value is called the derivative or slope of the tangent at the point x is equal to A. So there is a short formula is also there for this. Sometimes we will make use of that formula also. What is that formula is there now? So very easy to derive. So here A plus h is there now. Let A plus h is equal to some x. Let A plus h is equal to some x. See here, as h value approaches to 0. Now I am to change the limits also. As h value approaches to 0, x value approaches to A. As h value approaches to 0, keep 0, x value approaches to A. And also your h value becomes x minus A. Your h value becomes x minus A. Now you substitute all the values in the in that formula. So this is equal to limit. So this is a right hand side derivative, right hand side limit. H tends to 0 will become x tends to A. Okay. F of A plus h value is x. F of A is as it is by h value I will write down x minus A. This is also one of the easy formula. So to want to find out right hand side limit, right hand side derivative at A plus, so then easily we can write down limit x tends to A, f of x minus f of A by x minus A. So directly the function will be given. F of x is equal to some 2 sin x, f of x is equal to 2 into e power x. Directly we will write down minus f of A. We will substitute this A value by x minus A. Find out the derivative. Okay now. So this is a right hand side derivative. Same situation we will go there. So let A minus h. So here A minus h is there no. So here A minus h is equal to x. A minus h value is x. As we know that as h approaches to 0, x value, as h tends to 0, h value, A value approaches to A. H value as it is going on decreasing, x value approaches to A. Okay now, right. Now see this situation, and moreover A value is from this A only, then your h is equal to A minus x. Your h is equal to A minus x. Now substitute here. So this is equal to limit h tends to 0. Limit h tends to 0. So therefore this is a f of x minus f of A by f of x minus f of A by minus of A minus x. That is equal to limit, here x tends to A. We have to change the limits. So this is a x tends to A. This is f of x minus f of A by minus of. So h value is how much? A minus x. Here x minus A. So here you will get plus, here also minus, here minus you will get. Minus, that is equal to here. We are approaching a left hand side. So almost both formulas are same. Up to here same. Up to here same. Try to understand here. F of x minus f of A by x minus A. But here the thing is you are approaching x. You are approaching A from right side. Here you are approaching A from left side. So these two formulas are also very useful while solving right hand side derivative and left hand side derivatives. Understand this? I hope that you understand this concept. Okay. So let us see some more concepts. Let us see one of the very important theorem, that is, if f of x is differentiable at every point of its domain, that means f of x is a differentiable at every point. Differentiable means what? We can able to find a point and we can draw a tangent. That's all. That means, for example, so there is a curve here. I am saying that at every point, so every point in the any certain interval, the function is differentiable means what? We can draw the tangent. We can draw the tangent. We can draw the tangent. We can draw the tangible. That is the meaning of differentiable. Differentiable at x is equal to a means what? We can draw a tangent and we can find out the slope of the tangent. Okay, now that is called differentiable. So if f of x is a differentiable at every point of its domain, then it must be continuous in that domain. That means what? Take a domain x is equal to a and x is equal to b. In this interval, a and b interval, he is saying that differentiable, that means you can draw the number of tangents every point. For every point in the interval a to b, it is differentiable means what? You can draw the tangent. Then it must be continuous. It must be continuous. Then only we can draw the tangents. Then let us see that theorem. That means if it is a differentiable, then it must be continuous. But converse need not be true. That also I will explain. So first I will go through the proof of this theorem. Let x is equal to a belongs to domain of the function, domain of f of x. Let x is equal to a belongs to the domain of the function x is equal to a. Given, what is given? F of x is differentiable. F of x is differentiable. What is the meaning of this? F of x differentiable means f dash of a exists finitely. Exist finitely. F dash of a exists finitely. What is the meaning of this? This means both right hand side derivatives and the left hand side derivatives both exist and they are equal and f dash of a exists finitely. Now, what we have to prove? What we have to prove? At x is equal to a, f is continuous. That means it is differentiable. F of x is differentiable at, let us take x is equal to a. Differentiable at x is equal to a. What is the meaning then? What is the conclusion from that we get? F dash of x, f dash of a exists finitely. Now we have to prove that at x is equal to a, f is continuous. That means, that is what you have to prove? Limit extends to a, f of x is equal to f of a. Already we completed. Limit extends to a, f of x is equal to f of a. Then we say that the function is continuous at the point x is equal to a. This we have to prove. We have to prove this. Okay, now? We have to prove that. That is what is the meaning of this f of a constant, no? That is a limit extends to a, f of x minus f of a is equal to 0. It is enough if you prove that limit extends to a, f of x minus f of a is equal to 0. If you prove that, the problem is over. Now, for this what I will do now, let us take this left hand side. Don't understand this, try to understand. The left hand side is equal to right hand side. I am going to prove this. Left hand side is equal to right hand side. What is the left hand side? Limit extends to a, f of x minus f of a upon x minus a into x minus a. What I am going to do is now, for this left hand side, I am multiply and divide with the x minus a. I am multiply with divide with the x minus a. It is anything wrong in it? Nothing wrong in it. Why? Because x minus a value never equal to 0. Why? As x value approaches to a. X value, see here, try to understand here. Don't think that x is equal to a means x minus a is equal to 0. Not like that. Here x value approaches to a. Approaches to a. Therefore, x minus a cannot be equal to 0. Cannot be equal to 0. Okay, na? This x minus a value approaches to 0. Try to understand that point. See here now, I'll apply the separate the limits, that is f of x minus f of a by x minus a into limit extends to a, x minus a. Understand this? Up to here, what is your value? Up to here, limit extends to a, f of x minus f of a by x minus a. What is the value of that? What is the value? So this is nothing but f dash of a. Just now we have seen f dash of a. F dash of a value is how much? Just now I have explained that limit extends to a, f of x minus f of a by x minus a. Of course, here a plus or a minus, no problem, no problem. That is f of a into, as extends to a, x minus a value is how much? 0. This is equal to 0. So, limit extends to a, f of x minus f of a is equal to 0 means what? Limit extends to a, f of x is equal to f of a. Write it or wrong? Right, very nice. That means if f is differentiable at a point, then it must be continuous at that point. That is, if f is differentiable, then it should be continuous. Is there converse is true? That means if a function is continuous at certain point, it is continuous. Is it differentiable at that point? So let us see, let us check that using a very simple example. So from this total concept, we can conclude that. So what the conclusion is? If a function is differentiable, that means this is a curve. If it is a differentiable at x is equal to a, that means if differentiable at x is equal to a means there exists a tangent, there should be exist a tangent passing through that. It must be continuous. It must be continuous at x a. If it is continuous, it is differentiable means it should be always continuous. That means if it is a continuous, it is continuous. So here is x is equal to a, x is equal to 0. The function is continuous. It is continuous, but it is not differentiable. That means you cannot find a tangent here. Why? Because already we have seen right hand side derivative we got the value 1 and left hand side derivative we got the value minus 1. Both derivatives are not equal. Therefore, the derivative does not exist. That means the slope of the tangent it does not exist. Therefore, the tangent is also not exist. Okay, now. So therefore, differentiability and continuity both are different concepts. Different concept. If a function is differentiable at x is equal to a, then it is continuous at x is equal to a. If a function is continuous at x is equal to a, so it is no need that it is differentiable at a. Understand? So I hope that you understand these concepts. Okay, now. Now, in the next class, we are going to see that what is the reasons behind the non-differentiability of a functions. So, what are the situations where a function is not differentiable? What are the cases where a function is not differentiable? That we are going to see. Until then, all the best.